Chapter 3, Section 3 is on slope. So you'll recognize, many of you have recognized in the last couple of sections, we've been looking at linear equations and coming up with coordinate points to put on a graph. So just remembering all sorts of things that we went over in Algebra 1. The next thing that we're looking at now, of course, is slope. Slope, let's remind ourselves, is we represent it with the letter B, M, generally speaking. We also might call it a rate of change. A rate of change. This is kind of the most important phrase to remember, especially moving forward with your math career. So we'll talk about lots and lots of rates. Rate of change. You might also refer to it as speed or velocity, especially if you're in physics right now. You might refer to slope as these two ideas, given any particular situation. You might also remember that it's rise over run. And rise are the y's, so y over x. The change in y over the change in x. Okay, I'm looking at page 112 in your book. I'm looking at example 1. They give us 2 points and they ask us, let's find the slope between these 2 points. So I'm going to remember the slope formula. M equals the change in y over the change in x. I'm just going to use these 2 points to label. I've got x1, y1. The ones match. First is x, then y. x2 and y2. Now after I label, I can just use substitution to plug into my formula. So I've got m equals, I'm going to look at the y's first, y2, we've got -1 minus 3 over, and now we're looking at the x's, x2 is 4 minus x1, and the x1 is a -2. So we've got it plugged in. Now I'm going to remember that in the formula itself I've got subtraction in the numerator and in the denominator. So anytime that I see a negative number, I really should put it in parentheses. I didn't on the top, I can do that for sure. Didn't on the top originally because that negative number came first out of the 2, but it's always good practice to put negative numbers in parentheses, especially in this case. So I'm just going to simplify. So combining like terms and then simplifying down, I get -2/3. Now for slope, I really do want you to leave your answers in fraction form. It's going to make much more sense for them to be fractions than to be decimals. Now at the very end of a problem, maybe a given word problem, it might be make most sense to refer or write that final sentence explaining your answer as a decimal. But as far as understanding slope, it makes more sense to look at, okay, for every 2 units I go up, I go 3 units to the left, right? If I have these 2 numbers, not only is my answer the most exact that it can be, I also can see how the change in y relates directly to the change in x. Now I'd like you to try part B of example 1 and check your answer as it's written in the book. So now we're going to talk about slope in terms of this formula, which we were looking at in the last section, the standard form of a linear equation, ax plus by equals c. So if we've gotten, if we've got an equation, like I'm looking at example 2 on page 113, if we've got an equation that looks like -2, let me start that over. that looks like 5x minus 2y equals 20, right? So in this case, we've got a equals 5, b equals -2, and c equals 20. Just make a note of that to myself in case it becomes helpful in a minute. All right, so now if I want to find slope within this equation, I know that slope is the coefficient on x, but that's only really going to describe the slope if I have solved for y, right? So either in point slope or slope intercept form. I can remember that because they have the word slope in it. Slope intercept and point slope form, they both have slope in the name, whereas this has standard form. It's not written in order to be able to see slope immediately. So I'm just going to rearrange this equation and solve for y in the same way that we've been doing. So subtracting 5x from both sides, then you'll notice that I wrote -5x plus 20 in this case because I just want to keep this and make it look like slope intercept form, y equals mx plus b. So I just put this term first, then I divided both sides by -2. Now when I did that, I'm gonna just remind you that this becomes its own fraction, which is how I went here. -5 divided by -2 is a positive 5/2. Then I just wrote the x out to the side, which is the same thing as having the x written in the numerator. I also need to remember that this is the other part of the fraction, right? So I've got positive 20 divided by -2 gives me a -10. So here's another form of linear equation. You might remember y equals mx plus b, where in this case we've got m is 5/2 and b is -10. Now let's look at all of this information for a second and let's see if we can make any connections. So we've got this original linear equation. It's in standard form. I want to know the slope. I can't see the slope just by looking in this form, so I decided to solve for y. Here's y. Now I've got this form called slope intercept form, and this is where I can see immediately that my slope, or m, is 5/2, and then b, which is my y-intercept, is -10. Now I wonder if there's a shortcut from getting from here to here if all I'm looking for is the slope. I don't need the equation. Well, I notice that here I've got a 5 for a. Here I've got a -2 for b. And then here I've got a 5 and a 2. The negative's gone. So let's see. I wonder if the pattern works for any equation in standard form. I'm going to look and see if when I have an equation in standard form, if I take a, divide it by b, and make it negative, is that always going to equal the slope? Let's use this standard form to see if we can derive this shortcut here. Okay, so I'm going to rearrange this, solve for y, and see if I can see what the slope is. Given this, remember this slope-intercept equation, so I'm going to change this to look more like that. Okay, so let's see. I'm going to first make it just a little bit bigger so my handwriting is easier to read. And then I'm going to, let's see, subtract ax from both sides, which matches the move that I made right here. So then I'm going to have by equals negative ax plus c. And let's see, what did I do over here? I divided by the coefficient on y. So I'm going to divide by the coefficient on y. So I'm going to have, let's see, I'm going to divide by b, divide by b, and then I'm going to rewrite this as y equals negative a over b x plus c over b. Now I'm going to remember here the coefficient on x is my slope. Coefficient on x is my slope. Negative a over b. It's the same as negative a over b. That's a pretty cool shortcut. So it turns out that I can look at my standard form and immediately know what the slope is if I just remember to take the a, in this case up here, 5, divided by b, it's negative 2, and make this whole thing negative. And that will give me my slope. Pretty cool. Okay, the assignment now is starting on page 116. Just start with the written exercises. Don't worry about the oral exercises. The answers to the odds are in the back of your book. Remember to bring questions to class.